A is level, functions and graphs. Exam preparation questions, part 3. In the beginning, I first created the whole exercise as one video, but then I realized the video was too long. I don't want to make the video so long, so I break it up into 2. So this is actually the second part of doing this exercise. The exercise is try now 3. But let's start. Okay, so let's start with example 2. Express this in this form where A and B and C are constants, or A and B are constants. Okay, so let's just write it down. I'm just going to take a color. So it's 2x squared plus 12x plus 11. Okay, always it must be 1. So take 2 out as a common factor. Okay, so it's 12 divided 2, so that's 6x. And then 11, you can just leave it 11 over 2. And now you're going to add, take the middle, divide 2 and you square. And you're going to subtract the same, take the middle and you square. And then you're just going to close. Now, this is going to be your complete square. So this is going to be x plus 3, and it's going to be square. And if I simplify this, this is going to be 5.5 minus 9, and my final answer is going, and then don't forget that I multiplied with 2, and that's going to be negative 7. Okay, so then it will be, I think, negative 3.5, and then times 2, negative 7. Okay, so now it's in this form. Now number B. This was number A, now I'm going to look at number B. Find an expression for the inverse and state the domain. Okay, always make sure they ask 2 things. So now you will see that this, let me see. Now you see that this is exactly this. And don't forget it's smaller than negative 4. So just here, just keep in mind that the turning point will be negative 3 and negative 7. Okay, so basically, if I'm going to do it now, I'm going to say fx equals 2 x plus 3 squared minus 7. Okay, it must be in this form to get the inverse. So y is equal to 2 x plus 3 squared minus 7. Change that to an x, change to a y. Okay, then take it over. So x plus 7 equals 2 y plus 3 squared. I divide 2, I divide 2. Okay, so let's just move up. So I'm going to get, and now it's going to be plus minus. So plus minus x plus 7 over 2, and that's y plus 3. Then the 3 goes up, and don't forget it's negative 3. Okay, so let's write it just like negative 3 plus minus, and I will now look at the graph. I didn't look at the graph yet. I have to look at the graph to decide if it's plus or minus. Okay, so let's just get a picture. It can just really be a very rough picture, but it's just helping you. So negative 3 and negative 7. Okay, so if I'm going to, so it's negative 3 and negative 7. Say, for example, there. Okay, and now I know that if because it's positive x squared, the legs will be going up. Okay, but I told you also that if you look here, so x is smaller than equal to negative 4. So although the turning point, can I just show you first? Say the turning point is there, negative 3 and negative 7. Okay, so say something like that. Okay, doesn't, no, okay, it's sorry, I just want to that is more negative 7. Okay, say for example it's there. But now they don't want it there. They actually just make it even smaller. And they are going to say it's going to be at negative 5. So don't forget. Can I just show you there? Okay. So no, it's at negative 4. So x is at negative 4. So this is negative 3. But they want negative 4. Now, it's always good to get that point. So, negative 4. Let me get the point negative 4. So, basically, just substitute there 4, negative 4 in f, of f, negative 4. And then 2, negative 4 plus 3 squared minus 7. So, it's 2. So, it's negative 1 squared minus 7. So it's 2 minus 7, it's negative 5. So have that you know that point there is negative 5 and that point there is negative 4. Okay, you have that now in mind. So it's still going to work 100% because it's just that part. It can actually go up to the turning point there. Okay, but now what is the question? Let's go back to the question. We have it in inverse. Now, can you see that it's a decreasing? That's the reason why you are going to say, if you're going to write it, you're going to say f minus 1 x, and that's what I was first checking. It's the decreasing, not the increasing. There's the increasing plus there's the negative option. So it's the negative option. So minus x plus 7 over 2. That is the function. But now, what did they also ask me? And state the domain of fx. Okay, so basically that was the function. Now, remember, if I'm going to say it, this was f, this is fx. Okay, this is the original. Now, the other one is going to be a reflection in the line y equals x. Are you with me? So that point is going to be negative 5, negative 4. Okay, so I can say that the range, so what is the range of this function? The range of, let's rather say it like this, the range of fx is going to be, because remember it's from there, so y, I just want to see if that one was included. It depends if it was included. Yes, it's included. So do you see there? Where is it now? There's an equal sign. Do you see? So y is going to be, just want to say y is bigger and equal to negative 5. So therefore, can I just say, therefore, the domain of f minus 1x will be equal to this range. So x is bigger and equal to negative 5. So I'm just taking the original range and I just make it the domain of the inverse. Okay, as I showed you in the previous example. Now let's just go to the next one. Okay, so if I know, this was now that what they want. They wanted that and they wanted that. So make sure of your sign because it's the decreasing part. And then make also sure of that you can work with the original one there. Let's start with number 2c. Okay, I'm going to start by first writing down the functions. So it's 2x squared plus 12x plus 11. Okay, and they bring in the function g, and that will be gx equals 2x minus 3, and then they say x is smaller and equal to k. Okay, so they say, for the k where k is negative 1, so x is smaller and equal to negative 1. Okay, solve the equation. So if I'm going to start, then I'm going to say fg. So let's just start by saying fgx. So I'm going to take g, And now just be careful because there's two places where you see x. So it's going to be 2, and then it's 2x minus 3, and don't forget your square, plus 12, and then it's 2x minus 3 plus 11. We can first work this out. So it's 2, then if I do the short way, so I square the first term, I multiply with each other, so it's negative 6x, multiply 2, so it's negative 12x, plus 9, and then I multiply in, so it's 24x minus 36 plus 11. So this is going to be 8x squared minus 24x plus 18 plus 24x minus 36 plus 11. Okay, so let's just get our like terms. So this is 8x squared. This cancel out. Now, as soon as we take and we say 18 minus 36 plus 11, and we get negative 7. Okay, but now the statement is, and check here, they say if gx equals, so if gx equals 193. So it's 8x squared minus 7 equals 193. So it's 8x squared, and if I add it on that side, I'm going to get 200. And then if I divide by 8, and I divide by 8, I'm going to get x squared, and I'm going to get 25. And if I take the square root, plus minus, don't forget, then I'm going to get plus and minus 5. Okay, it seems to me I didn't clean so nice the previous one, so let's just clean it nice. Okay, but now the inner function, remember this is now in terms of an equation. Did you see? And can you remember what I showed you in example 1? The inner function, and this is the inner function, and that was x is smaller and equal to negative, determines now the domain, okay, in this equation. So if I'm, and I'm just going to write it here, so x is smaller and equal to negative 1. So it cannot be the positive. So therefore, x is equal to negative 5, and that's the only solution. Okay, so please remember that. As soon as you see an equation, that you look at the domain of this inner function to eliminate one of the solutions if necessary. Okay, and now number D. So again, I'm going to make space. And then I'm going to go to D. Okay, let's start with number D. State the largest value of K possible for the composition FG to be defined. Okay, now I'm going to bring, so now it's open. So let's just start with D. Okay, so let's just start here. So we can say in FGX, okay, remember Gx is your inner function. Now remember, the range of Gx, now you have the domain, you must just find the range. The domain of Gx becomes the domain of fx. Don't forget that. Okay. So the reverse will then also be true, because this is now, they want us to reverse back. There's not values. So if I put this sentence, which I wrote now, and I put it into reverse, so the reverse will be, so I'm reversing it back because they want the largest value. So the domain of fx, okay, so I start with the reverse. The domain of fx becomes the range of gx. Okay, so let's just start. So I was putting it in reverse. Now I'm going to start. So the domain of fx. So let's just go back. So here is the function, and can you see there is the domain? Okay, so I have the domain of fx. So that was x is smaller and equal to -4. Okay, so that domain becomes the range. So therefore, the range of gx, and remember to make it a y, is smaller and equal to 4. Okay. Now I'm going to put it in the, we remember, okay, where is this? Do I still have the functions now? Okay, I'll just work from here. So I have the function gx equals 2x minus 3. Now let's just go and substitute, I forgot that negative 4. Put it in the value place of y. And then I have -1, and then I have that x is -1 over 2. Okay, so therefore, so I'm basically finding the domain. Okay, therefore, the value of k is equal to -1/2. Because what was the question stating? State the largest possible value of k for the composite function. So I was working back to getting, can I just show you? Yes, the domain. So the domain of G, and then the range, and then this. Okay, and this is how I arrive at that -1/2. It's a bit challenging, it's a bit reverse, but it's not. Just do it more than once to make sure you understand it. Okay, let's do the final question in this video. It's a bit a long video, but I really just wanted to do these 3 examples. Okay, let's start with number 3. Now, it's nice if they give you a sketch, because then it's so much easier to see the range and the domain. So functions f and g, okay, so they give you the 2 functions. G, so this, and then they give you also the g, the quadratic. Okay, so this is function f on the graph. So the diagram shows part of the graph y equals fx. Okay, state the domain of the inverse. Okay, but first, let's start by saying, you can see the range from the graph. So you can see, okay, so the range of fx, you can see it from the graph, is going to be, let's just see, it can be y, and it's going to be all real numbers, but can you see it cannot cut that line? So, but y will just not be equal to 1. That is the range. Now, don't forget, the range, I'm going to make it another color, the range of fx is equal to the domain of f, let me just move it a little bit, -1, the inverse function. Okay, so therefore, if I want the domain, because the state the domain of the inverse, so therefore the domain of f -1 x, and now I'm basically just going to put in this place as x, so I'm going to say it's x is an element of real numbers, but x might just not be equal to 1, and that's how I do it. Okay, and then number B, find an expression for f minus. Okay, so let's start. The function is fx equals 2x plus 1 over 2x minus 1. So first put a y, Okay. Then I'm going to say, okay, in this case, I'm just going to make it an x. And every time I see an x, I make it a y. And now I just put brackets, put it over 1, cross multiply. So 2y plus 1 equals x, 2y minus 1. And I just multiply out. So I get 2y plus 1 equals 2xy minus x. Now, take the x, rather take the x to this side. So it's 1 plus x. And take the y's to the other side. I'm just trying always to avoid negative numbers. So it's 1 plus x, and if I take y out, then it's 2x minus 2. And I divide 2x minus 2, and I divide 2x minus 2. Okay, so I'm basically ending up with, I can already, no, this is not f minus 1. Let me just, yeah, that is f minus 1. Okay, because that cancel, so it's going to be 1 plus x over 2x minus 2, that side there. Okay, and that's what they wanted in that question. Okay, now they want the expression. Now it's nice, they want it for the inverse, so I have to do, I'm going to try to make it a bit smaller, and then rather write that you can see both sides, because I'm going to need this. This seems to me still from another question. So let's just get a nice line there. Okay, that we don't get, and if I need, I can just use it then. Okay, so it's GF. Okay, let's start. This is number C now. So it's GF minus 1, 3. Now, this is actually nice. So start with F minus 1 and substitute first that 3 in the inverse. So it's 1 plus 3. Okay, I just want to make sure it's not negative 3. It's positive 3. That's correct. So 1 plus 3 over 2, 3 minus 2. So it's going to be 4. And this is 6 minus, so it's also going to be 4. So it's going to be 1. So now they want G1. Okay, and where is my G function? Let's see, I think I have it here. No, it seems to me I already wrote it down. So let's just say the G, I first just want to write it down. So Gx equals x squared plus 4. So Gx is then going to be 1 squared plus 4, and that's going to be 5. So therefore, I can say that G, f minus 1, 3, the answer will be 5. Very, very easy. It's almost for me as if the calculations is very easy in functions, the algebra. The difficulty is it sometimes the reason to eliminate an answer or to find that domain or range of a composite function. That's difficult. Okay, but the rest is not difficult. Okay, explain why g minus x cannot be found. Okay, now the reason why, if you look at g, there is g. I'm just going to show you. Can you see it's a quadratic function? And can you see that if you go back, it was not a restriction. It was x is an element of R. So it was open. So it was like this. Now, it's not a one-to-one function. Do you see that? You have to restrict it to the turning point or less than the turning point to make it that, and this is what we said, a horizontal line must cut the function only one time, and now it will cut it how many times? So the reason what you will say, it's actually very easy. So in number D, say Gx is not a one-to-one function. Therefore, G, the inverse function, cannot be found. Okay. And I'm just ending off again the video just by showing you the bookshops. Make sure you have a copy. You must always go first to the basics. The basics is in the textbook. I'm just doing the exam questions in this video, or type of exam questions. So there's the bookshops. And then also, I want to also show the teachers. This is more for the teachers. They have a nice saying, and I'm going to repeat it 1 or 2 times. They say, if you fail to plan, you plan to fail. So make sure that you plan this year so that you have success next year. If you want to use the textbooks where the videos is based on, it's more than 1,000 videos already on the channel. And all the videos, most of the examples come out of the Y equals mx+c mathematics textbooks. And you can just see it on the NEET catalog. I highlight it for you. So make sure that you use the procedure prescribed by the ministry to order your books. We are actually blessed that the government is still buying textbooks.